Problem set 77, advanced radical equations, and then multiple radicals. Very mad at myself because I just did the whole problem. Got the wrong answer because I wrote down the problem correctly. Now it's written correctly. I'll never get those 5 minutes back. Now, in order to solve this, you got to solve for x, okay? But you can't just like bring this x to the other side and say, okay, well, x equals blah, blah, blah. You have to get rid of this cubed root. Now, what undoes a cubed root? Cubing something. Just like squaring something undoes a square root. But we cannot cube this term until it's all alone on one side. And right now it's not. These two things are on the left-hand side. So I need to move them to the other side. Opposite operation. I'm going to add x to each side and add 2. That'll give me x plus 2 over here. These cancel and are gone. So now, that's really just x plus 2 on that side now, right? So now we have this trinomial all alone, because this stuff is gone. We have this trinomial all alone. So we're going to cube it. Cube it. And what I do to one side, I must do to the other. So the cube undoes the cube root, and you're left only with what's left. X cubed plus 6x squared minus 4 equals, now this is tricky. We've been doing this for a long time. It's x plus 2 cubed, which is x plus 2 times x plus 2 times x plus 2. Cubed, 3 of them. So we can only do 2 of them at a time, right? So we're going to FOIL this here. X times x is x squared. X times 2 is 2x. And then 2 times x is another 2x. So that's going to total up to 4x. And then we do 2 times 2. Well, that's 4. So fellas, we've only done these two FOILed. Forget about that third one. We FOILed those two. Now we do the third one. Now it's times x plus 2. Now even though it's on the back side, we can still FOIL it to each term in the second set of parentheses. So first I'm going to do this x times each term. So x times x squared, x cubed. Excuse me. X times 4x, 4x squared. X times 4, 4x. Now we're going to go 2, and we're going to do each of the other terms in the other set of parentheses. So 2 times x squared is 2x squared. 2 times 4x is 8x. 2 times 4 is 8. So let's add those up. We have x cubed plus 6x squared plus 12x plus 8. Okay? This left-hand side, only thing that changed is we got rid of the cubed root by cubing it. So that what's left under there is still there. And what do you notice? They both sides have an x cubed. So if I subtract an x cubed from each side, then they cancel each other. Gone. Bye-bye. Oh, 6x squared, 6x squared. They both have a 6x squared. So if I subtract those from each side, they're canceled. Now I have 12x plus 8 equals negative 4. Oh, man. Well, we're almost there. We're on the home stretch. So you add 8, you're going to get 4 equals 12x here. Oh, shoot, that's plus x. Come on, Mr. Stroot. So that's minus 8. Sorry, that's minus 8. Excuse me. So that's going to be negative 12. Then you divide by 12, divide by 12. So x is negative 1. Now, you remember when you're going to be cubing and squaring sides, you always have to go back and check your answer. This is one of those types, guys. So once you have negative 1, you plug it into this equation. Negative 1 cubed, well, negative 1. Negative 1 squared is 1. So negative 1 plus 6 is 5. 5 minus 4 is 1. The cubed root of 1 is 1. Right? There it is. Cubed root of 1 is 1. Minus negative 1. That's going to be 1 plus 1. 1 plus 1 minus 2 equals 0. 1 plus 1 minus 2 equals 0. It works. You put a check mark next to it. All right? So that's one type. Now, what we're going to have to do is another type. I'm just erasing here. Just a moment. Don't leave, even though the screen is black. Now we have a problem that looks like this. Square root of k minus 5 minus radical k plus 1 equals 0. The big problem here is we have another kind of big square root. Here was a big cubed root. Well, here's a big square root. Oh, there's another square root. Same logic, though. To get rid of this square root, we're going to have to square that term only. So to square that term only, we got to get it all alone, which means we're going to add radical k and subtract 1. Add radical k to each side. Oops. And subtract 1. Those cancel. So now you have square root of k minus 5 equals square root of k minus 1. Right? This is all alone now. So what undoes a square root? Squaring. But what you do to one side, you must do to the other. The square undoes the square root. So you're left with k minus 5. K minus k. What the heck? K minus 5 equals square root of k minus 1 squared. Well, that means square root of k minus 1 times square root of k minus 1. Watch what happens here. Square root of k times square root of k, well, that's k, because the square roots undo each other. Square root of k times negative 1 is negative 1 square root of k. Negative 1 times square root of k is another negative 1 square root of k, and then negative 1 times negative 1 is plus 1. So right now we have k minus 5 equals k minus, these are like terms, so negative 1 of these minus 1 of these is negative 2 of these, negative 2 radical k plus 1. Fellas, do you see that there's a k on each side? If you subtract k from each side, it's gone. Now let's subtract 1 from each side. So we get negative 6 equals negative 2 square root of k. How do you solve for k? This is negative 2 times the square root of k, so we use division. What do I do to one side? Divide by negative 2, I must do to the other. Cancel, cancel. That's a positive number. So the square root of k must equal 3. So what does that number have to be? If you square it to undo the square root, and you square this side, you get, must be 9. You have to check this, though, against the original. 9 minus 5, 4. Square root of 4, 2. Minus the square root of 9. Right? So that's 2 minus 3, which is negative 1 plus 1 equals 0. And it works. They checked it, so we check it, right? But sometimes it doesn't work. So for instance, this problem on page 322, they go through the same rigmarole, and they get their answer as 9 for S. But when they plug it back in, okay, you get 9 minus 8, square root of 1 is 1, plus the square root of 9, which is 3. 1 plus 3 is 4. 4 equals 2. Doesn't work. So there's the correct wrong answer, and you have to put no solution. All right? Thanks, guys.